Hello students, let us start our first chapter of class ninth. Chapter 1 is number systems. In number systems, we will learn about natural numbers, whole numbers, integers, rational numbers and irrational. Let us start with the natural numbers. Natural numbers are denoted by n, capital N. We call the counting numbers as natural numbers. Counting numbers are our natural numbers. 1, 2, 3 up to so on. Our counting goes up to so on. So our natural numbers are also so on, that is they are infinitely many in number. Our next are whole numbers denoted by W. If we include 0 in the collection of natural numbers, we get whole numbers. If we include 0 in the collection of natural numbers, we get whole numbers. So these start from 0 and goes up to so on. 0, 1, 2, 3 up to so on. These are also infinitely many in number. Third are integers. Integers are denoted by Z or I. Along with whole numbers, if we take negative of natural numbers, along with whole numbers, if we take negative of natural numbers, we get integers. As we know, 0, 1, 2, 3 up to so on. These all are whole numbers. Now we include -1, -2, -3. Now this set becomes set of integers denoted by Z or I. In integers, we include natural numbers, 0 and negative of natural numbers. So integers may be positive or negative or maybe 0. I think it is clear to all of you. Next is rational numbers. Main topic is rational numbers denoted by Q. The numbers of the form P by Q. Numbers of the form P by Q, where P and Q are integers and Q is not equal to 0, are rational numbers. Numbers which are of the form P by Q and denominator not equal to 0, then those numbers are called rational numbers. For example, 4 by 5. 4 by 5 is a rational number. Here 4 and 5 both are integers. So this is our rational numbers. The rational numbers always denote the ratio of two integers. You can say that ratio of two integers. Rational means ratio. 9 by 10 is also a rational number. 2 by 7 is also a rational number. 0 is also a rational number because it can be written as 0 by 5, 0 by 1, 0 by 2, because 0 is an integer. If we divide 0 with any integer, we get 0. So 0 is our rational number. 3 is also a rational number because 3 can be written as 3 by 1, which is a rational number. So we can take so many examples of rational numbers. But 4 by 0 is not a rational number. 4 by 0. Because it is not defined. 4 by 0 is not defined. Here q is equal to 0. That is, denominator becomes equal to 0. So this is not a rational number. This is infinite or not defined. Infinity. Not defined. Because our main condition is denominator should not be equal to 0. Next are our irrational numbers. The numbers which are not of the form p by q are our irrational numbers. Numbers which are not of the form p by q, or we can say that the numbers which are not rational, they are irrational. Numbers which are not rational, they are irrational. Examples: under root 2 is an irrational number. Under root 5 is also an irrational number. Pi is also an irrational number. Up to so on. Now rational and irrational, these are also infinitely many. Here we discuss that natural numbers are contained in whole numbers. Natural numbers 1, 2, 3, 4, 5, 6, 7, 8 up to so on. These are contained in whole numbers because our whole numbers start from 0 and then all natural numbers. 5 is a natural number. 5 is also a whole number. So natural numbers are contained in whole numbers, or we can say that every natural number is not a whole number. Am I right? No, it's not correct. Every natural number is a whole number. This is right. Every natural number is a whole number. But every whole number is not a natural number. But every whole number is not a natural number because 0 is a whole number which is not a natural number. Similarly, every whole number is an integer, but converse is not true. Every whole number is an integer, but every integer is not a whole number because -3 is an integer, but it is not a whole number. 0 is a whole number, it is also an integer. So every whole number is an integer, but every integer is not a whole number. Then every integer is a rational number, but every rational number is not an integer. 5 by 2 is an example of rational number. It comes out to be 2.5, which is not an integer. So every rational number is not an integer, but every integer is a rational number. Irrational numbers are different from these, but the collection of rational numbers and irrational numbers are called real numbers. Real numbers contain rational numbers as well as irrational numbers. Is it clear? Now let us take some examples. Our first example is we have to find a rational number between 1 and 2. As we already know, there are infinitely many rational numbers between two integers. Rational numbers between two integers are infinitely many in number. But here we have to find only one rational number between 1 and 2. We have to find only one rational number between 1 and 2. For one rational number, we add these numbers and divide it by 2. That is 1 plus 2 by 2. We add these two numbers. 1 plus 2 by 2, which turns out to be 3 by 2. So 3 by 2 is our rational number between 1 and 2. Clear? Our second example is find three rational numbers between 2 and 3. Now we have to find three rational numbers between 2 and 3. For this, we will discuss three methods to find rational numbers between two numbers. Let us discuss our first method, which we have done in previous question. For first rational number, we add these two and divide them by 2. Answer is 5 by 2. This is our first rational number as we have done in first example. 5 by 2 is first rational number between 2 and 3. For second rational number, we take this 5 by 2 and first number 2, add them and divide them by 2. It means we have to take the average of these two numbers. 2 plus 5 by 2. For this, 2 is our LCM. We proceed like this. 2 into 2, 4 plus 5 over 2 into 2, which is our 9 by 4. So 9 by 4 is our second rational number between 2 and 3. For third rational number, we take the mean of 5 by 2 and 3. 5 by 2 and 3. For third rational number, we add these two and divide them by 2. Again LCM 2. 5 plus 6 by 2 into 2. And answer is 11 by 4. So we get three rational numbers 5 by 2, 9 by 4 and 11 by 4 between 2 and 3. This is our first method. In second method, we apply second method on same question. You can do with any of these methods. I discuss all these three. We have to find three rational numbers, so n equal to 3. N is equal to 3. N is the number of rational numbers. So n plus 1 equal to 4. According to this question, n is equal to 3, then n plus 1 equal to 4. Now we have to multiply and divide both these numbers 2 and 3 by n plus 1. This is a rule of method second. Now we have to multiply and divide both these numbers 2 and 3 by n plus 1. Here our n plus 1 is equal to 4. So we multiply and divide 2 by 4. 2 into 4 by 4, which is 8 by 4, and 3 into 4 by 4, which is our 12 by 4. As we know, 8 by 4 is less than 12 by 4. Denominators are same and 8 is less than 12, so 8 by 4 is less than 12 by 4. Now we have to introduce three rational numbers between 8 and 12. 8 by 4 and 12 by 4. So we start. 8 by 4 is our number, that is 2. Next is first rational number 9 by 4, next rational number 10 by 4, next rational number 11 by 4, next is 12 by 4. In this way, we can introduce three rational numbers between 2 and 3, or we can say that 8 by 4 between 8 by 4 and 12 by 4, because 8 by 4 is our 2 and 12 by 4 is our 3. So we simplify them. 2, 9 by 4 remains as it is, 10 by 4, 2 5s are 10, 2 2s are 4, 5 by 2, 11 by 4 remains as it is, and 3. This is our second method to find rational numbers between two integers or two numbers. Now let us discuss third method. In third method, we have to find D. D is difference here. Formulas of D is y minus x over n plus 1. Here x is our first number, which is 2 in this example. Y is our last number, which is 3 in this example. Or we can say that we have to find rational numbers between x and y. X is our first number and y is our last number. How many numbers we have to find out? That is equal to 3. So n is 3. Let us find D. D equal to y minus x means 3 minus 2 over n plus 1, which is 3 plus 1. It comes out to be 1 by 4. D is our difference. We get it equal to 1 by 4. Now three rational numbers between 2 and 3 are x plus d, x plus 2d, x plus 3d. X plus d. X is equal to 2 in this question, and d we calculated it is equal to 1 by 4. 2 plus 1 by 4, 2 into 2 plus 1 by 4, 2 plus 3 into 1 by 4. Now we simplify it. 4 is our LCM. 4 to the 8 plus 1 9, 9 by 4. We cancel it. 2 into 2 to the 4, 2 plus 1 by 2, 5 by 2. Similarly, we can solve it. 2 plus 3 by 4, 4 to the 8 plus 3, 11, 11 by 4. In this way, we can also find three rational numbers between 2 and 3. Is it clear to you? Okay. Now you have three methods to find out the rational numbers between two integers, between two rational numbers. You can adopt any of these. But according to me, our second method is best method and effective, easy method to find the rational numbers between two numbers. Let us take another example. Here we have to find 6 rational numbers between 3 by 5 and 4 by 5. As I have already told you, according to me, method second is better to use. So here we have to find 6 rational numbers. So our n is equal to 6 and n plus 1 is equal to 7. According to our second method, we multiply these two numbers by 7 and divide by 7. So 3 by 5 into 7 by 7. Numerator comes out to be 21, denominator comes out to be 35. Similarly, 4 by 5 into 7 by 7. Numerator comes out to be 28, denominator is 35. Now we have to introduce 6 rational numbers between 21 by 35 and 28 by 35. 21 by 35. Next is 22 by 35, 23 by 35, 24 by 35, 25 by 35, 26 by 35, 27 by 35, and last are number 28 by 35. In this way, we can introduce 6 rational numbers between 3 by 5 and 4 by 5. Now simplify them. First is our 3 by 5, second remains as it is, third remains as it is, fourth remains as it is, fifth we can cancel it on fifth table of 5, 5 5 is 25, 5 7 is 35, next 26 by 35, 27 by 35 and 4 by 5. I think this is also clear to you. So come to our fourth example. Find 4 rational numbers between 2 by 3 and 5 by 7. We have to find 4 rational numbers between 2 by 3 and 5 by 7. In this problem, the only difference is that the denominators of both the terms are not equal. In third example, we note that the denominators are same. But in this problem, the denominators are different. So for this type of problem, we have to take the LCM of the denominators. Here we have to take the LCM of 3 and 7, which is 21. So we have to make the denominators same, denominators equal. For that, we multiply first term by 7 and divide by 7. It becomes 14 by 21. And second term 5 by 7 by 3 and divide it by 3. Our result is 15 by 21. Now we have to find 4 rational numbers between 14 by 21 and 15 by 21. Now procedure is same as we have discussed in method 2. N is equal to 4. We have to find 4 rational numbers. N plus 1 is equal to 5. So 14 by 21 into 5 by 5. It is 70 over 105. And 15 by 21 into 5 divided by 5, 75 by 105. Now we have to introduce 4 rational numbers, which is very easy now. 70 by 105. Next is 71 by 105, 72 by 105, 73 by 105, 74 by 105 up to 75 by 105. You can simplify these. This is all about the introduction of rational numbers between two numbers. If any problem, you can contact me on WhatsApp or you can call me. That's all about today's lecture.